Welcome to the Naked Garden. I'm Paul Holowko. Today's subject is creating soil from clay, sand, and silt. With no other type of amendments, no other organic materials, but frankly, just by feeding biology and putting microorganisms and growing organic stuff in our soil, our bad soil, to be able to create new soil that we can use for vegetables or we can use for our yard. So come join me. Today we're going to be actually creating soil from really clay, sand, and silt and nothing else. No organic material to be added to this. And the process has actually been coined in 1916 and 1920 by two books put out by Frederick Clements. He put out two books, one called Plant Succession and the other one is called Plant Indicators. Now, in the book, he actually talks about what plant succession is. And what succession is the ability of one species of plant to be able to outcompete an existing species of plant in the same area, basically knock it out, compete it out, and then take it over. Well, the top one that survives after many, many years of a lot of species coming in and killing off each other is called the climax, or this is basically the place where it's kind of like a plateau where the plants will stop changing hands over that particular area. A subclimax is a place where it might stop for several years and stay at a particular plant and then continue on. For instance, a subclimax species would be coyote brush. Coyote brush is considered to be a pioneer plant that's on the edge of a forest. And why is it the edge of a forest? Is because the forest wants to grow out. Well, the soil that is in the fields that are surrounding a forest aren't necessarily always the best type of fungal, the bacteria type of dominance or whatever you need for the particular plants for the trees to grow. So you have intermediate species, and one of them is called coyote brush. And that will first grow out on the edge of a forest and then fortify the soil for what it needs to be, and then allow the other trees to be able to grow through. There are two different types of successions. There's a primary succession, and then there's a secondary succession. A primary succession is a succession where the rock is first formed by a volcano. Like, for instance, in Hawaii, a volcano will erupt and new lava comes out, and rock is then put down onto the ground. Well, at that time, water gets in there, and erosion with wind, water, and all the other business that goes on, it actually goes down into small little pieces called clay, sand, and silt. At that time, a cyanobacteria, which is actually a bacteria that is a nitrogen fixing. I think it's anaerobic, don't quote me on it, but I think it's anaerobic. That gets in there, and that's the first form of life of where we're putting organic material in the structures of our new soil, which is basically just really small pieces of stone. Secondary succession is where we take existing soil that has been compromised. Like, for instance, it has been totally obliterated, it's been basically left out in the sun, it's been left out with no plants on it, and there's really not much organic material or bacteria or microbiology inside the whole soil. So since it already has been inoculated with a lot of the organisms and has a lot of seeds of perhaps spores from fungus and a variety of different other things, chances are it will actually come back very quickly. So we don't have to go through the cyanobacteria issue of having a cyanobacteria start out by taking out really raw material and then moving it into something that's more traditional of what we have actually seen. Creating the soil is actually quite simple and is easy to do once you get the hang of it, and we're using the form of plant succession to be able to guide us on how to do that. What we're doing is we're taking Mother Nature's ways and methods and just accelerating them. For instance, it takes Mother Nature roughly about 300 years to make 1 inch of new topsoil. What we can do over here is roughly about 4 years where we do the right type of microbiology, add the right microbiology and the right stuff, and put it into our area and let it grow into this type of soil that we want. So when we're starting out this succession, we start out with several phases. But there are a few assumptions that we need to first get out in the open before we can really say we are actually creating soil. One of the assumptions is that you cannot put organic material on the surface at all. No mulch, no compost, no anything. Can't be anything. All you can do is put seeds, microbiology by inoculants, and then water. That's it. Anything that's taken off that particular area has to be put back on there. For instance, if we cut the entire canopy off of all the plants, we have to mulch it up and then put it back down there as a litter layer. The water can run off, but we can also have seeds of weeds and everything grow in there, and that's one of the benefits of this, because that's part of succession. We want the actual natural intertwining of other seeds and other plants coming in there to see who survives and how one overtakes the other, and that's how the strength comes of your soil. In the meantime, no matter what plants are in there, your soil is being nourished by whatever microbiology is being fed by the plant's roots that are going in there. So it's always a win-win situation, even if you do have weeds after a while. 4 major things that you have to consider and solve those problems and make decisions on in order to be able to make this whole process work. And they're actually quite simple. The first one is you need to feed the microbiology. Now, what's meant by that is all the microbiology in your soil, the nematodes, protozoa, all the fungus and everything like that, have to have a home. So the soil, as its little caves of nooks and crannies with like sand, silt, and clay, is a place where the animals, those type of animals will live. Well, if you want them to live there, you got to feed them something. So they basically, their heart is in their stomach. So the way you do that is you have to have organic material for them to be able to feed off. Now you can do it artificially by putting fish hydrogesate and then putting fish kelp in there, but what you want to do is you want to get the whole process going by itself, where Mother Nature takes over, not necessarily you always have to add more stuff into it. That's way too much work for me. You have to have a supply of water. What I found out by doing this method is your supply of water is huge in the beginning. So a lot of times if you're living in California, wait to do this for a particular area in your yard during the winter where it's a raining season, so you don't have to sit there and pump tons and tons of water into it. My point is, it's like rain is free water. Let's use it. All right, so tons and tons of water in the beginning to get things straight. Remember, next thing is we need to create a composting cycle. Now what that means is we have to create a litter layer, and that's the actual fourth element, is creating a litter layer for our soil. When we actually get bad soil, or first time we're trying to create soil from nothing, we have no choice. We don't have a cover. We have no litter layer on top, so all the water will be evaporated, and really a lot of the microbiology will be exposed to the elements. Well, Mother Nature can't do that. Means we can't do it if we're making new soil. So what we have to do is we have to learn how to compost. And when we have to compost is what we actually plant. So for instance, we have to look at the green to brown ratio change of a plant as it grows. How does it actually turn from a green for composting into a brown? Say we're going to take a plant that has a seed. Well, a seed generally has a carbon to nitrogen ratio about 10 to 1. When it germinates, what it is sending a roots down. And this also goes for perennials. It also sends down the roots, and it sends out a lot of candy, a lot of energy, and a lot of sugars for protozoas, fungus, and bacteria to eat. So you have all that stuff going on there. Generally about 4 weeks before a plant pops its head up out of the ground, you generally have this business going on underneath in the ground. So you have the bacteria is fixing nitrogen, nitrogen is going back into the plant is absorbing that nitrogen and is building things. Well, later on in the summer, we start going in the spring where we start growing a lot of foliage. Well, there's a thing called photosynthesis, which takes the carbon dioxide and then lets out oxygen. Well, what a plant does, it takes the carbon dioxide and takes the carbon off of it and uses it as its own form of like a protein to be able to construct more of itself. So what happens is now your nitrogen in your plant is still being uprooted and coming from the roots from the bacteria, but it's also being diluted by the amount of carbon that is in there. So now your plant is going to be roughly 30 to 1. So now you have a green plant, okay, take a look at it. You have a green plant that's absorbing carbon dioxide in the spring, and then it goes over and starts trying to flower. Say, well, hey, I have now enough stuff that I can actually reproduce. So what I'm going to do, I'm going to start making flowers. So now the flowers are being created on the plant. It's still 30 to 1. Once it has the flowers finished, it's going to start taking energy out of the plant itself to be able to make the fruit or the seeds that the plant needs to reproduce. What happens here is now the plant becomes into a nice skeleton. So we might have it now going to maybe 50 to 1. But when a plant has finished sending off its seeds and is dying back and drying out, it can be anywhere from a carbon to nitrogen ratio of 150 to 200 to 1. Well, that's the end of a season. Take a look at red winter wheat. Red winter wheat, once it makes its seeds or makes its wheat, the thing that you take, the rest of it turns brown and is really about 200 to 1 on a carbon to nitrogen ratio. Well, that's wonderful. So the last part is when the seeds are off, those are again 10 to 1, and then they start the whole cycle over for the next year. Now in a perennial plant, say a plant has already dropped off its seeds and is now ready to go dormant for the winter again. Well, what it does, it takes all the energy out of the plant and goes back into the roots. So now your roots have all the energy that the plants had. At the top of above the soil line is all tend to be 150 to 201, and then we start the whole cycle over next year by sending out more sugars and more food for the bacteria to be able to give it again more nitrogen, and the cycle goes over and over and over again. So here's the trick. What we need to do to make a litter layer for our succession area is we need to come up with a method where at the end of a season we have enough greens, enough browns in equal volumes so that we can compost it. Well, one method that I'm doing is by using fava beans, by clipping off the tops and letting it being a legume. And then the second is using that green, and then second using a red winter wheat or a barley after it seeds, then mulch it together and use that as a litter layer. So that's one solution to be able to do that. But you have to time it out when you plant everything and seed everything, and then also with the rains and so forth and so on. A litter layer also will have the advantage of keeping tons and tons of water in there. For instance, when you eventually cut your succession area in the first phase, cut it off, and then put the layers back down on it, you'll find out that the water evaporation has gone down tremendously. Now, has the compost material that you put on there gone to waste? Well, no, they dry out. But what happens is when you have a green type of plant that's been probably cut in the middle of its season, like these fava beans have, you'll find out that it dries out and it keeps its nitrogen in there. The only thing that will get the nitrogen back out again to be able to use as composting is to wet it up again. So you can have greens and browns dry out, but as soon as you get wet again, then you have to have them together in order to be able to make the compost and for the microorganisms and the fungus to grow. We come to a point here where we need to really learn what are the processes in how to actually create soil. And in the case over here, we have phase 1 and phase 2. We have to take a look at really a schematic of what we have. And what we do is here, we have the litter layer, we have the soil line, the roots, and the microbiology food underneath. And you can actually split them into 3 areas. So you have the canopy that's above, that's actually going to be our organic material to be able to make our succession work, and that will eventually be our litter layer. Once it comes into a litter layer, it then is put on top of the soil as ground up, and then fungus and water retention can occur. Underneath, what we do, we need to also put in organic material inside the soil itself, or in this case, the sand, clay, and silt, and have it stay there. For instance, when we harvest this thing, we don't dig up the roots. Well, here we're actually building the structure by having all the roots of all the different plants intertwine with each other and create actually housing for things to go into. Our compaction is 0. We want no compaction, that we can have our microorganisms, our protozoa, our fungus be able to grow through, and our roots to be able to grow extremely deep in order to be able to grab the water. The trick here is to build that particular layer and then keep it. So what you do is you don't want to walk over your succession area if you're trying to create soil, because what it does, it'll make compaction. If you weigh 200 pounds like I do, then it'll compact roughly about 8 inches down underneath your foot. It doesn't necessarily compact in the surface, but it compacts lower down, which is actually worse because your roots then can't dig in there. Now, a lot of questions I get is, should we put inoculants in here? I have put in VAMs in here, and I have put in a whole bunch of azobactis and things like that. So as part of this succession, as part of the definition of this succession, is we cannot put anything into this area and we can't take anything. So now we're ready to start making our own soil. So what we do is, we really have to start out with just clay, sand, and silt, and we put some inoculants in there for azobactis or rhizobia or anything like that. And then we need to use plants that we can put in only as seeds to be able to make the whole thing grow. In roughly about 4 years, we'll end up having a decent soil that I want to do as a grassland. Now, when choosing to make your own soil, you got to choose what kind of soil, what you want to grow in the soil. And what you want to grow dictates what kind of soil you want to use, or what you want to. Decide first what you want to grow in there, and then that will dictate what kind of soil that you want. So if you want to grow conifers, you're going to take longer to be able to get there than if you are going to do bushes, or you're going to do a type of shrubs or just perennials, or even a grassland. So what I suggest is, if this is the first time you're doing this, then choose something that's actually native to the area that you're at. Like, for instance, if you are living in a grassland area, then choose a succession, a climax, or a soil type that is more suited for that, because you'll find out you'll be more successful and easier in the beginning here. Later on, you can play around with different plants afterwards to be able to make something new or something farther or different than what you're planting in your native area. But in the beginning, try to do your native. In this area, we're doing oaks and grassland, and that's what kind of natural climaxal succession is over here. So all the soil will generally try to go toward that. The next part we have to do is we have to stress our soil as we're growing. For instance, we have to work the soil. For instance, we have the microbiology in the soil. We have the protozoa, the nematodes, and all that kind of stuff. We have it in there. What we do is we need to work it out. So we have a legume or a nitrogen fixer being absorbed by some sort of plant that eats a lot. For instance, we're putting wheat with fava beans. Well, in this case, we have the fava beans making the energy. We cut the tops off. The protein is released from the nodules, goes through the bacteria to be able to come into a nitrate, and then is absorbed by the wheat. So that's how we do that. We have to actually cut off the top of the fava beans, because we don't want them to go to a seed, because we want to use those as a green. So we use the fava beans as a green in our compost, and then we use the wheat as our browns in our compost at the end of the season. That's how I calculated how to do this particular area. So what we do next, after learning all this type of stuff, what about actually doing a project to see if this thing really works? Well, it does work. I did it in my front yard on the mow strip. So roughly about 6 months ago, I decided to take out the cement blocks out in my front yard. This is the mow strip between the driveway and the street. And what's going on there is the cement's being removed, and there's just clay, sand, and silt underneath that. And I got roughly about 8 yards, 10 yards of trash dirt. This is stuff that's been from someone's backyard that was sent to the landfill to be able to be just dumped in there. And then they just gave it to me, and I put it over here. And then I put down this particular new dirt, this new soil. The next thing I need to do is plant my fava beans. So the recipe that I've decided to do is to use fava beans, red winter wheat, barley, and white clover, and then putting a watering system on here. So the watering system is really, I'm trying to imitate rain. So for instance, all I have, what Mother Nature is teaching me, is to use this area as a rain area. So I decided to use a sprinkler. Now they're lossy, and yes, you guys can tell me that, yeah, why don't you go ahead and use a drip irrigation, you might be better off. Well, I'm sorry, it's not rain. So I'm trying to go as true as possible with Mother Nature, or what Fred Clements talked about in his books. So here he is, and we're making it rain. So we have these little twirly-dig sprinklers, and it rains. And then after a few weeks, it comes up. And to my surprise, because of the combinations of everything together, it works. The fava beans are coming up, the red winter wheat's coming up, and I start looking deeper and deeper into the canopy inside there. And it's fun to really watch because I'm not really doing anything other than watering this. And in here, since we're now in the winter part, I don't even need to water this, so the sprinkling system is not even on. This is growing on its own, and the roots are very deep. Once in a while, I'll take the plants out and I'll dig them up and take a look at the legumes to see how well the plants are doing, to see if there's any compaction or anything like that, and make observations. Some observations I've made by this about succession. I found out that the succession, the climax for this particular mow strip right now is fava beans and the wheat. It killed off Bermuda grass, which seems to be a problem here in California, and also killed off dandelions. And I had some voluntary marigolds that are starving for light. My favorite one is when I found one voluntary thistle that wouldn't grow at all. I mean, it sat there for literally a month or two, and it wouldn't even grow because it just was starved by all the nutrients and all the light that came in or not come in for it, and it just could not grow. It was absolutely incredible. So I actually had a mono patch by simply putting in a few different plants that I knew that would be doing a cycle of stressing the soil. Next thing to do is actually phase 2. My goal here was to really make this whole mow strip into something that really looks nice and I don't have to water it and so forth and so on. So phase 2 here was to make the mow strip into something of more fungal. So I wanted to change the bacteria to fungal ratio from probably bacteria to fungal 1 to half or 1 to whatever. So I started looking at the microscope and I started observing how much fungus is actually coming in here. When I first started and I looked at these microscope pictures, I actually had no microorganisms in there at all. Now I have roughly about 3,000–4,000 of them per microgram per gram of soil, and now I actually have fungus. Look at this picture here. This picture here is showing actually a fungus germinating. That's actually a hyphae coming out of a spore that's germinating with a cluster of aggregate of bacteria. That's absolutely amazing. And here's some more pictures of bacteria that's just growing, and I see other pieces of fungal that are in there. So you can take a look at the fungus and you can tell ones that are pathogenic and the ones that are not pathogenic. The pathogenic ones are generally very narrow and clear. They're generally about 1 micron wide. And while the non-pathogenics or the helpful type of fungus are generally about 3 microns wide, or 3 widths of a bacteria. So you can see here a small little bacteria going around, buzzing around here. Bacteria doesn't buzz around like that. That's the light around the microscope and the focusing of how the light is being pushed up underneath the microscope to be able to make these pictures. So bacteria doesn't bounce around like that, but it's kind of convenient that we can actually see that. But what's going on there, one bacteria is 1 micron, and then the width of a fungus is roughly 3. So that's not a pathogenic or a disease-causing fungus, that's actually a beneficial one. As I dug more and more into the succession area, I found huge clumps and patches of fungus, just in clusters of fungus in different places. When I took these samples, it turned out that I wasn't very good at it. I didn't get those particular samples, so there were clusters here and there. So I had like maybe I have 10,000 micrograms per gram of soil of fungus in this area, which it was growing tremendously. So it totally blows me away, and how that all really worked out. And simply by putting out there, letting it water by itself, or during the winter, don't even water at all, and let it just grow. The last part is you can see some of the other plants are growing in there. You can see in the edges by the sidewalk, you can see how some of the weeds are coming in there, but they don't seem to be intruding at all. Last, we go to phase 2, which basically we take this entire caboodle. Since the wheat right now has turned into a brown, we take the wheat and we take the fava beans and we combine them together, mulch them, and put them back as a litter layer. So what we do, as time goes on, I use a chipper, and the chipper is off to the right over here, taking a machete and chopping off all the wheat and all the fava beans off at the bottom of their canopy, and not taking up the roots. I'm leaving the roots in there. I have one clean mow strip that is incredible. And what's incredible about it is that it preserved water like you wouldn't believe. I was totally blown away. I did not water this afterwards, and a week later I stuck my finger in there and it was soaking wet, while my grass is dry. My other beds are dry because of this process of having all the organic material and all of the roots all intertwined and tangled together. It actually kept the water in there and didn't allow it to escape. Now the top layer is totally dry. That's totally bone dry in the top. The next process, as in phase 2 here, is that we need to now make it more fungal dominated, because I'm going to go for a grassland, which is roughly 1:1, 1:2 on bacteria to fungus ratio. So I decided to start putting in lupin. Now native lupin is a nitrogen fixer, and this one is an azobactus one. So this is not anymore a legume, or it doesn't take a rhizobia, it takes now azobactus. So now we put the lupin in there, and I put seeds all along. So I just take a poker and seeds it all along and put seeds everywhere. And I then put another layer of strawberries. The strawberries are small little plants that I have in the corner. I do native strawberries, of course, because it's easier to do it with the natives than it is easier to do it with exotics from the area. So I put the strawberries in. Those are, remember, bacteria to fungus of 1:1, so they like more of a fungal type of dominant soil, so they're going to keep that soil dominated. I am also planting lavender, tarragon, thyme, and woody type of herbs out there as well. So when all the seeds come up, you'll have all this big mishmash of different type of plants growing in there out of the essence of what the fava beans and of the red winter wheat that was there before. Now, will there be seeds from the red winter wheat in there? Well, yeah, of course there will be, because chances are I grind it all up together and just put it in there and let it have its way. So that's it. Now we have actually a successional area where we'll have a purple lupin land, and we'll get to see which plant takes over where. So what will be the climactic succession of this area? Chances are it'll be the perennial lupin and / strawberry. Chances are I don't think the herbs are going to make it. I don't think the lavender works, but that's my guess, and we'll see that in probably the next 6 months or 8 months. But now what we have created is soil that is from clay, sand, dirt, from a basement. We actually made it now 1 to 1.5 from bacteria to fungal ratio to maybe 1 to 2 on bacteria to fungal. Thank you for watching The Naked Garden. I'm Paul Holowko, and I have to give special thanks to Freddie Clements, the guy who does on plant succession and plant indicators. He did a fantastic job in 1916 for publishing those particular books, and I'm hoping to do a lot more with this in the future. Have a great day.